Hi everyone, I am Özgün and my friend Oğuzhan will introduce you our microprocessor systems project. Let's start with introduction. While starting this project, we were inspired by the Google Chrome's popular dinosaur game. The reason behind this selection is this game is simple, everyone knows it and it's suitable for assembly programming. Before started coding the game, first we found the original image of the game. Then we made some adjustments like reducing the size and made their background black for our screen.
For this project, we used Keil's simulator UVision 5 for assembly programming on ARM architecture. And we were given an LCD peripheral which has some buttons for user interaction. Basically, we are playing the game on this peripheral. And we use Discord application to communicate with each other. We shared ideas and did many troubleshooting sessions. You can see our work environment here.
We used many subroutines and loops in implementation process. We have subroutines for drawing the dinosaur, cactus, floor and health bar. Also we have a subroutine to perform jumping animation. Then we have a main loop that contains all of these subroutines and we have a game over loop that waits for a user interrupt to reset the game. You can see previews of our subroutines and loops in these slides.
We use button handler for dealing user interrupts that generated by button presses. We used just two buttons, button A and button up. Button up allows us to perform jumping animation of dinosaur, whereas the button A allows us to reset the game when the game is over. You can also see the coding preview of our interrupts.
This game basically runs in a big main loop that contains all drawing subroutines. In the main loop, it checks every time whether the jumping happens or game is over. Actually, jumping is a subroutine and main loop every time calls it. If jumping happens, it will do its job and return to the main loop, and if jumping will not happen, it will do nothing and turns back to the main loop. If the game is over, the program goes to game over loop and it will rapidly check for user to press restart button or not. When restart button is pressed, the program turns back to the main loop.
Let's move on to how the game looks like and how it works. First of all, we use black background design due to performance issues. We have a moving floor, walking dinosaur, and a cactus that continuously moves from the right edge to left edge of LCD. Cactus disappears from the left side and comes back from the right side again. The dinosaur has a jumping animation that moves up and down. Finally, we added the health bar feature to the game for variety and playability. In one run, Dino has 5 of health symbols, and every time it touches the cactus, one health symbol will disappear until there are none left.
We faced so many difficulties during the implementation of this game, such as jumping the dino, touching condition, game over condition, and code size limits. For most of it, we handle with using RAM. We store 10 or 15 variables in RAM and use them for checking different conditions. We want to add more visual objects, but the code size limit limited us. Also, we have an issue that we couldn't handle is sometimes there weren't any interrupt created even though we pressed the button. Our lecturer told us maybe there is a problem with LCD peripheral, but we couldn't overcome this problem. Luckily, this issue doesn't affect gameplay so much. In worst case, we can press the button multiple times and eventually it creates an interrupt. Let's see some gameplay. I'm waiting for game over happens so I will reset and start. So that's end of our presentation. I hope you liked our projects. Thanks for watching.